The observable part of the universe spans about 90 billion light-years. It's hypothesized that the unobservable territory beyond our observations could be significantly larger. The cosmos is so vast that the human mind, at least at present, cannot fully grasp its expanse. However, some theories suggest that the universe might be smaller than it appears. Today, we'll attempt to guide you across the bridge connecting the macro and micro worlds, based on modern data. The unobservable part of the universe might have a diameter of approximately 20 trillion light-years. Just imagine. Based on existing data, it's plausible that most of space should be empty. Explored space contains incredibly little matter. Gazing into space, we see vast, boundless expanses of icy emptiness. But what if the entire universe fits within a single atom? It sounds absurd, doesn't it? Don't rush to dismiss this idea as philosophical fantasy. Recall what we know about matter. Any matter consists of tiny particles, atoms. These minute building blocks form the basis of our world, yet they are so small that even with the most powerful optical devices, we can't see them. An intriguing fact is that we can't confidently know how atoms truly appear. We merely speculate about their structure based on scientific data. Although we can't see atoms with the naked eye, it's proven that they're comprised of smaller subatomic particles like neutrons, protons, electrons, and quarks. Modern research asserts that atoms are so numerous and minuscule that the average adult human body contains approximately 7 octillion atoms. This quantity can be envisioned as a 7 followed by 27 zeros. The structure of an atom itself possesses intricate organization, prompting us to contemplate the theory of the microcosm. If we were to peek inside an atom, as studied in chemistry classes, it consists of a nucleus formed by protons and neutrons, with electrons orbiting around it. This model, proposed by Ernest Rutherford in 1911, is known as the planetary model of the atom. Its analogy to the movement of planets around the sun is evident. Even contemporary research confirms that the movement of electrons is described by the laws of quantum mechanics. This leads us to question, what is the size of our universe? Does it sound absurd? In reality, this number is impossible to process even for the most powerful computer, let alone the human brain. But what if I tell you about a hypothesis called the One Electron Theory, proposed by American physicist Richard Feynman? According to this theory, there exists only one electron in the world, moving so rapidly in space and time that it creates the illusion of numerous particles, thereby shaping our entire universe. While this theory lacks broad support due to the principle of electron identity, making it impossible to experimentally distinguish one electron from another, it cannot be refuted. Let's return to the structure of the atom and consider the incredible theories it generates. Let's try to answer the question, what is the size of objects? The concept of size is a mysterious one. In reality, understanding the size of objects is relative. The world around us seems tailored to our size. Yet natural creations can be enormous or microscopic. It's interesting. Do ants consider themselves small in a world of giants? When we gaze at cosmic objects, we ourselves seem microscopic. This thought provokes reflection. The great master of horror and fiction, Howard Phillips Lovecraft, suggested our insignificance before the vast cosmos. And here arises the main question. What if our universe could fit on the tip of a needle? Or even the solar system is just a part of something larger? Therefore, it's logical to assume that even in those microscopic particles constituting our reality, an entire world might be hidden. This supports the idea that infinity is limitless. Ultimately, our reality might be merely a subatomic level of an entirely different reality. Just as our subatomic reality might contain entire worlds, infinitely in both tiny and vast scales. It sounds incredible, but exploring the improbable is our task. The most astonishing aspect of studying the observable universe is the realization that it all begins with tiny particles, such as atoms, and ends with vast cosmic bodies and star clusters. From your lunch today to a recently discovered exoplanet, it's all made of the same building blocks. The dream of the scientific world is to unlock the theory of everything, establishing a connection between the microcosm and the macrocosm, which is the key to this theory. Young scientists experimenting with quantum mechanics and classical physics might possibly comprehend the true nature of our universe, including what lies beyond its boundaries. Even one of the most popular versions of the universe's origin supports the idea that it began with an infinitely dense and small singularity that then expanded to its current size. This is the Big Bang theory, something tiny becoming something immense. It may seem coincidental with what we are discussing today, the micro and macro world, but there's an important note. The small singularity that led to the Big Bang, despite its small size, contained all the necessary elements to form the entire universe. However, labeling it as originating from a single atom would be a mistake. There's also string theory, a contender for the theory of everything. The fundamental idea is that not atoms, but something resembling vibrating strings, form the basis of everything. The interaction of these strings explains almost all known laws of physics, including gravity and quantum mechanics. However, string theory has its weaknesses, such as explaining dark matter. Scientists, despite the complexities, are attempting to unify string theory and dark matter. In late 2018, Swedish scientists proposed a new version of string theory, suggesting that our universe exists on the border of a constantly expanding bubble. They proposed viewing our entire cosmos as oscillations on the surface of this bubble. What remains a mystery is what happens inside this bubble or beyond its boundaries. Perhaps our entire world is just a part of a larger whole. It might even be merely a fraction of reality situated on the surface of this bubble, which itself might be part of something even greater. Why do we not feel or comprehend this? Perhaps in the same way your sunglasses are made of the same particles as plastic. Yet that doesn't diminish their importance. Whether we obtain a definitive answer to this question is irrelevant. We should be grateful that our vast universe is full of such amazing mysteries. Our task is to explore them, and we hope our video has sparked your interest.